So I came across this vending machine the other day, and the question I asked myself was to buy or not to buy. Would you buy this dollar bill from the vending machine? Nope, I probably wouldn't either, because it costs $2. You have to pay $2 to get $1. That doesn't really sound fair. But if you think about this vending machine, right, if we push 10, right, if we push this 10, what will come out? That's the question. What comes out? Oh, yeah, $1. What about if we push 11? What comes out? All right, a Kit Kat. So we know how vending machines work. We push these numbers, and the things inside should come out. So if we look at it as an X and Y table, what's going in could also be called our input. So the input was 10. What came out, or our output, was $1. What we pushed was 11. That's our input. What came out was a Kit Kat. So as we move into these equations, these are still like vending machines. Except this time, this is our function. Instead of candy that's coming out, we're going to get numbers that come out. And we know from the last video that we looked at that we can use this equation, y equals 3x minus 2. Our inputs, remember, are our x values. Our outputs are our y values. So here, our equation is 3x minus 2. But now, instead of x, we have this -1 right here. So this is our x value. So we can erase this x, and we're going to put in our -1. That's our input. And remember, when there's a number next to a variable, we're multiplying. It's like 3 x's. So that's why I put the parentheses there. So 3 times -1, I know, is -3. And -3 minus 2 would be moving left on the number line, so the output here would be -5. Second one, same 3. 3x is our equation, minus 2. Taking out the x, putting in my x value, which is 1 in this case. 3 times 1 is 3, minus 2 is 1. Last one here, 3x minus 2 is our equation. We take out our x value, or we take out the x, we put in the x value, which in this case is 4. 3 times 4 is 12, minus 2, our output is 10. So that's how, when we look at a table, we can go from our x values, our inputs, use our equation to find our outputs. Now we're going to look at what that looks like on a graph. So this is my same equation, same inputs and outputs. Now I just have to graph them. So remember, our inputs are our x values, and our outputs are our y values. So these are our coordinates, x, comma, y. So -1, -5, I'm going to move left, start at the origin, move left -1 on the x-axis, then I'm going to go down -5 on our y-axis and plot my first point. So this point is -1, -5. So I did this one. Next one is 1, 1. So again, starting at the origin, going over 1 on the x-axis, going up 1 on the y-axis. This is my second point, 1, 1. Then the last one is 4, 10. Starting at the origin, going right 4 because it's positive on the x-axis. Then going up 10. This is my last point that I figured out, 4, 10. So now what we do is we can connect these with a line. And last time what we looked at was with functions. Every time we have the same input, so none of these inputs are repeating, but if I did repeat it, say if I put 4 here again, and if I use this same equation, 3 times 4 minus 2, which I get 3 times 4 is 12, minus 2 is 10. So that means that this is a function because each input has one output. Each input has one output. So looking here at this graph, if I wanted to graph this last point, it would also be right here. I'll just make the dot a little bigger. It's still at 410, right? Because this third one and this fourth one are exactly the same. So now we know that from the function table, or the input-output table, that it is a function. So let's see how we can tell that from a graph. So this is our same graph from the last one. We know that the equation was a function from the input-output table. Now let's check how we can find that on a graph. So instead of using my equation this time, I can use my graph to find my answers. So if my input is 2 is my x value, I can find 2 along my x-axis. Oh, that's -2. I'm going to find +2. And then to find the y value for it, I just need to go until it intersects with my line. So if I go over here to 2 on the x-axis, I'm going to go up until it finds the y-axis. Oh, well, it hits the line. I'll use orange just to make it different. So that's my point for 2, 4. So that would be this point right here. There's only one point. If I keep going up, there's no other point where this line crosses where x equals 2. I can check this whole graph. There's no other spot where the line crosses. So I know that 4 is the value here. Now if I try for 3, if I come and find 3 on my x-axis, right here between 2 and 4 would be 3. So again, I can look down. There's no line that crosses. No line that crosses. No line that crosses. Oh, there it is. So here is my next point. And if I look over this way, it's between 6 and 8, which we know would be 7. So this point here would be 3, 7. So again, if I keep going up, there's no other place where this line crosses. So I know that each one of these inputs has one output because the line that we have only intersects the x values at one point along the line. So then from the graph, we can also tell that the graph is a function because each input along the x-axis only has one output. We could find exactly what it was. So we already knew that this was a function from the table. That means the equation is a function and the graph is a function. So here, using this graph, if we have an input of 2, let's find what the output is. So again, 2 is our input, which means it's our x value. So our x-axis, trying to find 2, right here. What is the output? So if I go down, there's no line. If I come up until I intersect, right here. So the output would be 8, or y equals 8. So the point here would be 2, 8. So I want you to pause the video and see if you can find the outputs for these two. If your input was -4 and your input was 0, what would your outputs be? And then see if you can figure out whether it's a function or not a function. So here's what your answers should be. For an input of -4, that would be along this line right here. There's only one time where this dark blue line, the line that we have, crosses or intersects, and it's right here at this green dot. And the value of that is -4. So the output here is -4 for an input of 0. Again, I'm going to trace the line to hopefully make it a little easier to see. This would be an input of 0. And again, this dark line only crosses it at one point. So the input of 0 only has one output, which is 4. Right here at this green spot. And as I look at all of the vertical inputs, right, -6, -8, -2, 2, the black line, our original line, only crosses those vertical lines one time each. That means each input has one output, which means it is a function, because each input has one output, which we know is the definition of a function. So let's check this second graph. So first, I just want you to look at what's different about it. Yeah, what you should notice is normally our graphs have been looking like this, just one line. But this one has a second line at the bottom. So it has a positive slope and a negative slope. So here, again, let's look and check the inputs and outputs. The input of -1. So the input of -1 would be here. So again, if I draw my vertical line on -1, that's what we're looking at. It's asking what is the output. Oh, well, I see that the lines intersect at this point and at this point. That means there are two outputs. So this first output would be about 2, y equals 2, or y equals 1, -1, -2, -3, -4. So there's two outputs there. Well, we know that if there's two outputs, then this is not a function. Two outputs for one input. Because input of -1 has two different outputs. We can check +9. We already know that this isn't a function, but we can check the others. So if the input is 9, that would be this vertical line right here. Again, the red line crosses that twice. Once here at 8, y equals 8, or y equals -7. So again, that confirms what we said, that this is not a function. So what that would look like with points or coordinates, the first one would be -1, 2, and it would also have another coordinate, -1, -4. So those would be the 2 points along the -1. And the second one, it would be 9, 8, and 9, -7. Again, the inputs have different outputs, so it's not a function. So I want you to go ahead and figure out if these are functions or not functions. So these should be your answers. This is a function, function, not a function, not a function. The last two are not functions because if I take this input of -1 and draw my vertical line up and down, the graph that we have, the dark line, hits this point 2 times. That means the input of -1 has an output around 3, that's an estimation, and the input of -1 also has an output at -3. So this is not a function. Same thing here. If I draw my vertical line on, let's say, -5, I could try here, I could try here. Sometimes they call this the vertical line test, so looking vertically on a line, see if it crosses twice. So crosses twice on this line, on this line, on this line, confirming that it's not a function. For these first two vertical lines, it only crosses once on each. So it's a function. Same thing with the first one. Even though it is curved, it's not linear, it's not a straight line. Anytime you take the vertical line, it's still the line you had, only still crosses once. So both of the first ones are still functions. Because we know that a function means every input has exactly one output. Now this has confused some people. This is a totally separate question. The question here is linear or nonlinear. What do we remember that linear means? Yeah, linear, the word itself has the word line in it. So straight line. Right, so go ahead and label each of these as linear or nonlinear. Hopefully you got nonlinear, linear, nonlinear, and nonlinear. So going back here, even though this was a function, this is a nonlinear function. And this one is a linear function. So don't get those confused between linear or function. It can be a nonlinear function, it can be a linear function. So don't get those mixed up. Remembering that linear means straight line. The word itself has line right in it. And problem solved. So remember, as we learned, functions on a graph, it still means each input has one output. And making sure that we remember linear means straight line. So this is linear and a function, non-linear function, and this is a linear function. So remember those differences. You have 3 Khan assignments for this video. So go ahead and log on to Khan and go crush these videos.